Welcome, Pre-Calculus 2.3, Dividing Polynomials, where our objective for this lesson is to learn to use long division and synthetic division to divide polynomials. Polynomial long division is a method for dividing a polynomial by another polynomial of a lower degree. It's very similar to dividing numbers. When we divide numbers, for instance 12 into 277, we find that 12 doesn't go into 2, but it does go into 27 2 times. We do 2 times 12, we subtract, we get the answer. Well, we're doing the same thing with polynomial long division. We look to see how many times this term will divide into this term. And x goes into 2x squared 2x times. So then we take this 2x and we multiply it times the x and times the 2. We put the result here. We subtract these from the number above. I like to change the signs of them and add. It's the same difference. But subtract these. Take it away from the top number. The result, 3x, and carry down that 7. Now we see how many times does x go into 3x. Well, it goes 3 times. 3 times x is 3x. 3 times 2 is 6. Subtract, we have 1 left. 1 is our remainder, and we can write that as plus 1 over x plus 2. Any questions? Please feel free to email me. You may email me at mr.d.math@gmail.com. That's a more direct email than the one that we'll get if you just respond to the YouTube video. Anyway, if you didn't get that, go ahead and back it up, pause, write it down. Moving right along, divide using long division. Okay, so we're going to set it up. We have to identify the fact that these are not in order, and the first thing we're going to do is we're going to put them in order. That's standard form, the highest power on the variable first. And when we do, we'll notice we don't have any y to the firsts in here. So we have 0 y's. And we need to write that in there or we're going to get all mixed up in our division. So we put it in standard order and then we set it up just like we would a division problem using normal numbers. Okay, so here we are again. How many times does y divide into 2y to the third? Well, it divides in 2y squared times. 2y squared times y is 2y to the third. 2y squared times minus 3 is minus 6y squared. And then we, of course, have to subtract this. Again, I prefer to change the signs and add, because here we have y, negative y squared minus negative 6y squared. That just to me seems like an opportunity to lose a sign, and so this is what I would do. I would change the signs and then add. It's the same as subtracting. Okay, so these cancel each other. 6y squared plus negative y squared is 5y squared. Bring down that 0y, and let's do the next step. We see plus 5y. Right? Y goes into 5y squared 5y times. That's all we've done. How many y's are in 5y squared? Well, there's 5 y's of them. Now we multiply. But when we multiply, we have to multiply each of these. So 5y times y is 5y squared, and 5y times minus 3 is minus 15y. And again, I would change the signs and add. That's easier to see that 15y. Bring down the 25. Now we're looking at how many times does y go into 15y. Well, y goes into 15y 15 times. 15 times y is 15y. 15 times minus 3 is minus 45. And again, here we have to subtract negative 45. It's easier. Change the signs and add. These cancel. 25 and 45, 70. That's a remainder of 70. Whoops, I want to go back for a second. This PowerPoint, I did not add the last part in here. 70 over y minus 3. Remember, if this was a number, if we were dividing by 3 and we had a remainder of 2, we would have to do plus 2/3, right? We put our remainder over our divisor. Okay, well, moving right along, write the final answer. Now, there you go. 2y squared plus 5y plus 15 plus 70 over x minus 1. So here, divide using long division. Another example. Now we're dividing by something with a lead coefficient greater than 1. So again, we have to set it up, make sure that it is in standard form, including any terms with a coefficient of 0. Here we don't have any. Step 2, write it the same way we would when we were dividing numbers, and it looks like this. And we move right along and we go ahead and we divide. 3x plus 1. Notice 3x goes into 15x squared 5x times. And then we take and we multiply the 5x times each of the terms in our divisor. 5x times 3x is 15x squared, and 5x times 1 is 5x. We do our change the sign and add, subtraction, whatever you choose. 3x minus 12, we find 3x goes into itself once. We do our math. 1 times 3x plus 1 is 3x plus 1. We subtract this. Change the signs and add is my way. Negative 12 and negative 1 is negative 13. That went away, so we find a remainder of negative 13. And I would put minus 13 over 3x plus 1 right there. Again, use your fast forward, use your rewind, use your pause buttons. And if you're not using a pencil and a paper to write this down and to work each step, and if you don't understand why we put that there, figure out what you could do to the numbers that would make that have to be there. And that's a way that you can learn the mechanics of this. You can learn how these operations are happening, kind of by almost like reverse engineering them from the answer, finding how you got to the answer. Final answer. Okay. Now let's look at synthetic division. It's a shorthand method of dividing a polynomial by a linear binomial. And we'll use only the coefficients. For synthetic division to work, the polynomial must be written in standard form, again using 0 and a coefficient for any missing terms, and the divisor must be in the form x minus a. In other words, let's look at this. Synthetic division method. Okay, if we want to divide 2x squared plus 7x plus 9 and divide it by x plus 2 using synthetic division. Okay, well, I'm going to come over here, and we have to keep in mind that with synthetic division, we're only going to use the coefficients. The 2, the 7, the 9. If we had a missing term here, like let's say we had no x's, that would be a 0, and we'd have to have that 0 in here. Okay, this isn't the case in this one. So what we do is we put what x plus 2, we put what x is when x plus 2 equals 0. We solve this, set it equal to 0 and solve it. It's the opposite sign. Instead of a positive 2, we get this negative 2. And that's what we're going to put here. Now we take our first number and just copy it down. And then we're going to take this number, multiply it times this number, and write the answer here. And this is showing that we've done that here. Then we combine these two. Write it there, and then we take this number times this number, and we're going to write it here. That's what's happened here. Negative 2 times 3 is negative 6. Now we combine these two. This number is now our remainder. And because we started with x to the second power, a second degree polynomial, our answer divided by an x to the first power is going to be an x to the first power. So this 2 is the coefficient in front of x, and this is our constant, and this is our remainder, because everything has dropped 1 power on x. Let's look at a better example. Okay, so step 1, find a. X plus 2 equals 0, so a is negative 2. Step 2, write the coefficients and a in the synthetic division format. Notice right away, there is no x squared term here. And so we're going to have a 0 for the x squared terms. Okay? Use a 0 for the coefficient of x squared. So when we copy this down, we put our a, we put negative 2, then we have 3, negative 1, 0, 5, negative 1. 3, negative 1, 0, 5, negative 1. Now we're ready to go. Drop this number down. 3. Negative 2 times 3 is negative 6. Combine these. Negative 7. Negative 2 times negative 7. Positive 14. Combine these. Negative 2 times 14. Negative 28. Combine these. Negative 23. Negative 2 times negative 23. Positive 46. Combine these. Our answer will be, since this began at x to the fourth, it will be 3x to the third minus 7x squared plus 14x minus 23 plus 45 over x plus 2. Now I know I spoke that, I didn't write it, and I went fast, but I did so because we're going to see all of this happen again in front of us. Negative 2 times 3, negative 6, negative 2 combine, negative 2 times negative 7, positive 14, combine, negative 2 times 14, negative 28, combine, negative 2 times negative 23, positive 46, combine, remainder 45. Now we write the quotient again. We started with an x to the fourth, so our answer is going to begin with an x to the third. Take these as our coefficients. 3x to the third minus 7x squared plus 14x minus 23 plus 45 over x plus 2. Again, use your pause, your rewind. Let's look at another one. Again, find a. A is negative 3. X squared, x 6. We've got all of our terms in order, no missing terms. We set it up, negative 3, 6, negative 5, negative 6. Okay, drop the 6 down. Negative 3 times 6 is negative 18. Combine, negative 23. Negative 3 times negative 23, 69. Combine, and this is our remainder. So the answer is 6x minus 23 plus 63 over x plus 3. Watch, 6x minus 23 plus 63 over our divisor, x plus 3. can use synthetic division to evaluate polynomials. This is really cool. If I want to know what f of 3 is, if this is f of x and I want to know what f of 3 is, I can put the 3 in here, right, and then do the synthetic division, and my remainder is what f of 3 is. In this case it says p of 3. So, and this is called the remainder theorem. You put in a number, whatever the remainder is the evaluation of that number that you've put in that function. So we could do this if you wanted to. 3 to the third is 27 minus 4 times 3 squared minus 4 times 3 squared. 3 squared is 9, 4 times 9 is 36, plus 5 times 3, 15 plus 1. And we'll see, we'll get 7 out. But this way is a little bit easier. 27 minus 36 is negative 9, and positive 15 is 6, plus 1 is 7, exactly. So we just put in our number that we're going to evaluate, do the synthetic division process, and the remainder is p of, or f of our number. P of x equals all of this. Evaluate it for x equals 2. So we want to see what p of 2 is. That's what that's saying. So we write it, set it up in synthetic division, bring the 2 down. 2 times 2 is 4. Combine is 9. 2 times 9 is 18. Combine is 17. 2 times 17 is 34. Combine is 41. So right here, p of 2 in this function is 41. Substitute it. Substitute it. It works. Okay, thank you for your time, attention, and attendance.